For the first 2 weeks of November 2025, passengers using trains on the Heart of Wales line may have noticed a curious ceremony taking place as trains arrived and departed from Llandeilo and Llandovery stations. They may have seen a yellow box being placed on or being removed from the headlamp bracket of the diesel multiple unit. And the eagle-eyed may also have noticed strange green discs appearing in the track between the running rails. Railway signalling causes significant debate. It's safety critical because the consequences of signalling failures can carry the highest safety failure tariff of all. But signalling is complex and expensive. Re-signalling schemes are notorious for running over budget and over time. Where it becomes really problematic is on more lightly used rural lines. Here, the business case for ETCS is going to be much more challenging. And that's a problem because 65% of signalling assets will expire in the next 12 years. Up till now, we've had a rather all-or-nothing delivery style for signalling schemes. So when a technology innovator comes along and proposes something that could dramatically reduce the cost of re-signalling on more lightly used lines, it grabs attention. And when they go on to say they want to start small and build organically, proving each stage as they go, it sounds even smarter. And their name? Universal Signalling. I've come to the Heart of Wales line in rural Wales to see a trial which, if successful, could prove to be a genuine game changer. First stop on my trip was Pantyfinnon, the former junction with a branch to Abernant and Gwaun Caergywyn. Here is located the signal box that controls all the user-worked crossings on the Heart of Wales line. It's pouring down with rain as we walk from the station to the signal box. I'm told that's not unusual for this part of the world. Stephen Head, the CEO of Universal Signalling, climbs the steps to the signal box to ask the signaller on duty if it's okay to come in and have a look at how things are currently managed. There are 126 user-worked crossings on the 96 miles of the Heart of Wales line, and they are all managed from here. On the panel are buttons for each one, and when a user arrives and wishes to cross, they pick up the phone and the respective light flashes. The signaller answers the phone and advises the user, often a farmer, whether it is safe to cross. The problem is, the signaller does not know exactly where the train is in each block section, merely that it is in a particular block section. The user cannot cross safely until the signaller confirms the train has left the section. And with the longest block section being around 40 minutes, that can cause delay and real frustration. Stephen and colleagues from Network Rail discuss with Sean, the signaller, the current layout of equipment in the box and how the new system might look if implemented, a system we are about to go and view back at Pantyfinnon station. The system is very simple. U-beacons are placed on the track, roughly 30 sleepers apart. The train has a simple box placed on the headlamp bracket. Inside the box is a beacon reader, which communicates back to base using high-grade commercial mobile communications for which the connection is extremely reliable. It's all very elegant because the beacons can be installed without any design work. They cost less than £30 per beacon fully installed, and the readers in the yellow boxes means no modifications need to be carried out to the trains. Brilliant. Back in the beautifully restored Pantyfinnon station building, we see a computer monitor showing a live feed from the beacons and the beacon reader on the train out on the 11-mile trial section between Llandeilo and Llandovery. Stephen Head explains exactly what is happening.
So on the screen here, you can see the green line. So that's actually a lot of green dots, 769 of them. At the bottom, you can see the pin showing the train's location. So it's just entered the section from Llandeilo at the bottom. You saw as it entered the section, all of the boxes lit up. So each one of those boxes is a user-worked level crossing. And these boxes represent what information we can present to the signaller. So you can see the first cluster are showing red. That's because the train is very close to the crossing, so within the 3-minute decision point, and therefore is danger, should not let anyone cross. You can see the pins just about to pass the first crossing. So once it's clear and we are sure it's clear, and there's various checks and balances around that, that box will go green, indicating the train has passed that user work crossing. You can see the crossings further up the line, currently showing amber. So these are outside of the 3-minute decision point at the minute. So the train is approaching them, but the signaller could, within the rules, let a train cross there at the minute, and we can indicate the time that the train would get there. Now that's a conservative time based on the train going line speed before it would get there. If we flick to the other tab, so this is a representation of what the signaller would actually see. So 1 box per level crossing, a very simple set of information. You can see, green ones where the train has passed, red one, the train is either on the crossing or imminently on the crossing, and the ones further away, the signal is given a clear indication of how many minutes until, or the minimum number of minutes before the train could get there.
And at the moment, the signaller, if somebody calls up and asks, can I go across the crossing? At the moment, the signaller has to say no to everybody everywhere, because he doesn't know exactly where the train is, he just knows it's in that section.
It's correct. And so sometimes you might hear them say, have you seen the train pass? And that's allowable under the rules if the crossing user had actually witnessed the train going past. So that is allowable in some scenarios, but generally, yes, they just have to refuse crossing. Here we have a 25-minute block section. The longest one on this Central Wales line is at 40 minutes. So users could be waiting 40 minutes before they are given permission to cross the line.
Whereas if this was implemented, those 5 user work crossings that have gone 6, that have gone green, the signaller would be able to say, you can now cross, because I know that train has passed.
Yeah, and potentially all the amber ones as well. So
because they're outside the 3 minutes.
Llandeilo, 8 minutes. If it's a single car, if the user's confident they can get across in 2 minutes, which is the normal time for a single car, the signaller could let
And those times are calculated on line speed, so it can't get there any faster, is that right?
Correct, yeah. So these are the most conservative times.
Time now to go and see the kit in action. We arrive at Llandovery, and after a full safety briefing from the COS, who explains this section of line has a full block, there will be no trains at all during our site visit, we walk onto the track to prepare the kit for the night's work. We're here at Llandovery now. We're at the first of the work sites. We've just gone beyond the end of the station to where the points are. The guys are just setting up the survey staff that they're going to be using to do the beacon installation. Fortunately, the rain's just eased off a bit, so it's not quite as wet as it was before. The clever electronics on the survey pole that is going to be used to log the precise GPS location of each beacon during the beacon installation survey is protected by an adapted bird bath. £10 from Amazon. Excellent.
Bird feeding bowl. Waterproof umbrella, full thing.
Sam Bement, Chief Innovation Officer, explains the purpose of the survey pole.
So this is our beacon survey staff. At the top of it is a GPS RTK receiver. It's a technology commonly used in site surveying. So it's currently booting up, it's finding all of its satellites. You can see how many satellites it's got and its current accuracy, so that's to 188 millimeters in X, Y and Z. By the time we start moving down the track, it will have dialed itself into about 10 or 20 millimeters in X, Y and Z. So every beacon we put down the track centre line, we know exactly where it is to within 10 or 20 millimetres, and that's how we create our track map afterwards.
To be able to carry out the beacon installation and log the GPS location efficiently, a rail-borne trolley is used on which the survey pole will be attached. Sam explains the process of installation.
Okay, so the team are now spreading out, and we've got quite well practiced at how to do this. So right up front, gentleman right up front has a drill. He's also got a drill template, which makes sure we drill the holes in exactly the right place for each beacon. And off he goes drilling in. So it actually doesn't matter where he drills that hole. We're aiming for about every 30th sweeper. But if he gets to the 30th sweeper and it's rotten and we think it might be replaced soon, or there's, say, a TPWS unit there, AWS magnet, we can move them forwards and backwards a little bit, doesn't matter. So he's made the holes and marked that sweeper, or bearer rather. Off he goes. The beacons are fixed using kind of railway standard hammering fixings. So these fixings can be removed with a screwdriver, should we ever want to take a beacon out, but to make it quick to fit, whack them in.
And that's it?
That's it. Yep. We've used those fixings for years for things like track circuit tails. They're widely used in the industry, so that's what we went for. And now the trolley, this is the clever secret sauce. The trolley parks over the top. On the bottom of the staff is a beacon reader. Oh, he's already done it. We'll have to talk you through it on the next one. Off we go. Okay, so we're 30 sweepers down the line. We're at our second beacon of the evening. The trolley's going to park the staff over the top. On the bottom there is a beacon reader. The beacon's got a unique code. So our computer now knows the unique code of that beacon. The GPS I described earlier knows where we are, and there's a little bit of processing in here to get the right readings from the GPS over a period of time. My colleague here, Stephen, is going to push the button. And that beacon is now in a log in here, captured with all of its data, ready for transfer into our safety critical database.
The process is swift. Walking pace is required to keep up with the installation team. Whilst passing through Llandovery station, we hit an error code during one beacon installation procedure.
That's a quack. That means it didn't work. It's a shame we didn't get that. Oh, did you get? There we go.
But Sam explains exactly what happened and why it demonstrates the accuracy and resilience of the system.
So that was a good demo of a potential error there. So in that case, Stephen had a beacon in his hand. He had two beacons in view of the antenna.
Right.
So the system went, I shouldn't ever be able to see two beacons.
Okay.
So you need to sort it out and let me know which one I'm actually logging.
Right. Brilliant. Even a road level crossing provides no barrier to installing the beacons. As we watch the team disappear into the darkness to install the beacons beyond the station, I chat with Sam about the team's vision for their system.
Sam, signalling, it's hugely expensive. It takes forever. It seems to involve complexity upon complexity. You're trying to deliver a low-cost solution. What is it about what you're doing that is different?
Signalling is expensive. It can be complex, and it nearly always takes a long time. And we believe that the primary driver of cost in any signalling project is that time. Time it takes to go through the whole project life cycle, from the idea of re-signalling somewhere, the need to re-signal somewhere, doing your signal survey, coming up with various different design options, down selecting them, detailed design, etc., right through to testing and commissioning. Around 17% of the cost of any signalling project actually goes on clever electronics or track circuits or troughing. 83% goes on labour surrounding those processes. So any attempt to reduce the cost of signalling purely by throwing new technology at the situation isn't going to help unless we can really target that labour cost. That's exactly what we've done with our approach. We have tried to reduce the whole signalling project life cycle in every way we can by automation, automated data collection, and self-verification.
And the process that you're adopting does seem to be low cost, off the shelf equipment. Is that, I mean, I presume that's by design.
It's a conscious design decision to keep the costs down and also to help eliminate issues with obsolescence.
How fast could you actually get a signalling system in if this all works?
Well, we're currently demonstrating our user work crossing protection product, and we fitted 11 miles of track using the process you've seen in the video and out on track here. 11 miles of track in 2.5 overnight line blocks using a 3-person team, and that was without any prior design work before coming to site other than a quick review of the AVA footage to see if there was any hazards that we might need to be aware of on the evening. The data from that is fed immediately into our safety critical database after a human review, and that can be used the next day by trains to report their position back. So we can do train detection in a matter of days. We're looking at rural signalling, specifically low-cost rural signalling. It will take us a long time, and it's a very different proposition to be able to re-signal Euston Station throughout, for example. The Heart of Wales line is an ideal first line for us to deploy on. The user work crossings, there's 126 user work crossings here and 96 miles. Obviously they present a huge barrier to the public either side of the railway if they're having to wait 40 minutes sometimes to cross if there's a train in a long block section. So anything we can do for those guys, brilliant. But also it's a long thin line with a single fringe either end, so when we come to upgrade the functionality in time, it gives us the perfect sort of caged area to show what we can do. We define our market as up to about 8 trains per hour either direction. But we're
Okay,
not-
so that's actually
reasonably,
that's
yeah.
almost like a secondary route, isn't it?
Yes,
I mean, that's
yeah.
not okay. So
Yeah.
I get the sense from having been here and chatted to people, this is a project of many people and many parts. I mean, getting access to the railway is not a straightforward task. You need to do that sort of together with Network Rail. What's it taken to pull together something like this?
It's been hugely collaborative. So Network Rail have been wonderful, very supportive, both Wales and Borders route here, getting us access out on track, providing sponsorship for the project, and general advice on how to do things, to go from what was, to be honest, quite a radical idea and getting it out there on the railway. Transport for Wales have been great as well, so we've been fitting our test equipment to their trains on nearly every service on this line for the past week and a half. We'll continue to do so to the end of this week. Conductors and drivers have all been really interested in what we're doing, very supportive indeed. And we received some funding from the Innovation Acceleration Forum centrally in Network Rail, which was set up to help small companies like us access the railway and see if we could make a difference.
So how much time do you need to capture the data you need to be able to say to yourself and to Network Rail, look, it really works?
We'll be monitoring this installation now for some time. It's a 2-year trial officially, but we're going to come back very regularly and look at the degradation state of the beacons we're putting in. The system is massively redundant, so we don't need every beacon to work for the system to work, but we need an idea of how regularly the beacons are failing. We think we'll have a good idea of that in about 6 months, so we can start making wider rollout decisions.
So literally in 6 months, you could be saying to Network Rail, look,
we're confident.
We're confident it's going to work.
Yeah.
Okay.
This all sounds really exciting, but at the end of the day, it all depends what the client thinks. And the client is Network Rail, a large organisation who in the past have been a little slow to innovate perhaps, but not anymore. The sponsor for this trial is Nick Millington MBE, Route Director for Wales and Borders, who is well known to want to change the way things are done, improving safety, reducing cost and speeding up time.
In the Network Rail Wales and Borders route, we've got some very experienced people that understand how to bring innovation into the railway, to deliver trials, successful trials, and then roll out that innovation in a live setting. So we're keen to work with suppliers, and it's been great working with Universal Signalling over the last year. We've got great support from our technical centre, from the trades unions, from our train operator customers, our own signallers. So on this particular trial, it's been a real joy to bring something different to our railway.
Why here? Why this particular route then?
So Wales and Borders, we've got a lot of rural routes. Okay, we've got over 400 user work crossings across our whole network. There's not a great deal of money around, so we need to use something different. We need to innovate our way to a safer space. So on this particular route, we're not going to spend an awful lot of money resignaling it. We've got about 100 user work crossings, and it is the skill of the signaller in the signal box that will keep agricultural traffic separate from trains. There is a failure rate with that, inevitably. But what we're doing here is working with Universal Signalling, and we are providing accurate train positioning, decision support tools, and a way to support the signaller and the agricultural community along this line. You can just imagine during harvest season, time equals money for farmers. The margins are thin. If a farmer has to wait at a user work crossing for tens of minutes, that is dead time. That is, if you look at then time versus risk, who knows what happens? Genuinely, who knows what happens? We're out in rural mid Wales here. What we're able to do here is provide more assurance, decision support information to our signallers.
If it works here, it's replicable in many other places like this, presumably.
This is a trial. We've talked about the length of this trial, how fast we've managed to mobilise this trial. We're already in conversation about how do we extend the trial for the whole length of the line, from Craven Arms right the way down through to the bottom end of the Central Wales line. But also we've got other rural lines. We've got the West Wales ports, we've got the Blaenau Ffestiniog branch, and there are more besides, more use cases besides. So we'll be working with Universal Signalling. Once the trial, and we've got enough confidence, we'll be in discussions about how we can expand the trial to make the railway safer, but at a cost that is affordable to everybody.
Anyway, we've come to the end of the evening shift. The guys have done about 1 kilometre of beacon installation from one side of Llandovery station right the way through over the level crossing and then back actually. So we've done both lines. So this is the first station in the world actually that's got these beacons installed within the station, so passengers will be able to see that in the morning. The rain didn't ease off very much, but wasn't too bad. And yeah, a fantastic project, and it'll be really interesting to see how this develops over the coming months.
I'm immensely impressed by this trial. I love the focus on cost and speed, whilst at the same time improving safety. If I were a farmer in the middle of a 40-minute block section on the Heart of Wales line, I'd literally be banging on Network Rail's door to get this done. This can only improve Network Rail's relationship with its stakeholders dramatically. And the fact that the trains don't need to be modified, you just pop a box on a lamp bracket, that's genius. Pure genius. But what of the future? Could Ucross develop further? Well, Universal Signalling believe it can, as Sam explained. They believe it is the initial building block towards low-cost rural signalling renewals and enhancements. Today, Ucross. Tomorrow, perhaps a full supervisory control and signalling system. Who knows? Maybe the thought of a re-signalling project won't cause the same level of furrowed brows in the future. And maybe Universal Signalling's vision of signalling in days, not in decades, can become a reality. Now that would be genuinely transformational.